Linear programming is one of those lessons that students beg for. Students in math classes who inevitably want to ask, when am I ever going to use this in everyday life? This lesson is for you. Linear programming is something that businesses across the country do literally every day. It's about making decisions in order to optimize some quantity given certain limitations, restrictions, or constraints. I've got a problem here that we're going to work through as an example for how to approach this process of linear programming, particularly for two-dimensional scenarios. That is, scenarios where there are just two unknown quantities that we're deciding between, and typically there are going to be some number of constraints, which we will turn into inequalities to graph in a coordinate plane and then use finally to optimize for some given objective, trying to make the most money possible, trying to charge the least money possible, trying to make the most friends, as we're going to do in today's example, etc. This is a problem from the Art of Problem Solving's Introduction to Algebra textbook. It's problem 9.40, so if you have access to the book, you can look that up. But I've also got it displayed on the screen over here. Let's go ahead and get into it. This year, I'll have 180 hours free during which I can play video games or watch movies. Each movie lasts 2 hours, and I'll play each video game for 20 hours. I have $600. Each movie costs $10, and each game costs $40. What I typically recommend is that we want to begin by asking ourselves on these kinds of problems, what are the constraints? That is, what are my limited resources that are going to help determine how much time I spend on blank, whatever it might be. In this particular case, you can tell there are two limited resources. There's the time I have to actually watch the movies and play the video games, and then there is the money I have to spend on the movies and the video games. In both cases, these are less than or equal to constraints. I have up to 180 hours. I have up to $600 to spend. So those are our two constraints. We'll even jot down, just so we remember for the future, this first constraint is about time. This second constraint is about money. From there, we want to ask ourselves, what do we not know? The answer to this question is going to be our unknowns. It's what we're going to use to assign variables. So we're going to assign variables. In this particular case, the unknown is how many movies do we watch? How many video games do we purchase? And so we're just going to say x equals the number of movies that we watch this year, and y will be the number of that's not how you spell video games. That's also not the number of video games. We want variables so that we can go back to these constraints and write some linear inequalities. Linear in two variables, x and y, and we're going to graph these on a coordinate plane in a moment. For example, let's think about our time inequality. We know that each movie lasts 2 hours. Now, we don't know how many there are. That's why we assigned that a variable. But imagine that we chose to watch 5 movies this year. If each one of them is 2 hours, 5 times 2 makes 10 hours devoted to watching movies. If I watch 10 movies instead, it's going to take 20 hours. But what's important to recognize is in each case, I'm taking whatever that number of movies is, 5, 10, or our unknown x, and multiplying it by 2. And so that's what's going to show up in the inequality. 2x accounts for the number of hours that I spend on movies. 20y is what's going to account for the amount of time I spend on video games. So we end up with this linear inequality. 2x plus 20y is less than or equal to 180. We're going to do the same thing for the money. We're looking for some kinds of numbers in the problem that we can use as weights or coefficients. In this case, you can see each movie costs $10, and so in our inequality, that's going to show up as 10x, and each video game costs $40. So that's going to show up as 40y. And there's our second inequality. 10x plus 40y has to be less than or equal to 600. That is the $10 per movie times the X number of movies plus the $40 per video game times the number of video games is going to be less than or equal to the $600 that I have to spend. Now, probably the best thing to do at this point would be to utilize some kind of graphing calculator to graph these two inequalities and figure out the points that we need to know, all of which represent possible solutions in this problem. But before we go to the calculator, we are going to use Desmos here in a second to do this. Before we go to the calculator, I just want to think through broad strokes. What are the kind of most extreme possibilities? Concentrate on just one inequality at a time. Let's think about only the time that we have to spend watching movies and playing video games for a second. If I spend all 180 of my hours just on movies, that is basically if I ignore the video games entirely, how many movies could I watch? Well, you can tell, first of all, let's say that this is equal to rather than less than, because we want to use all 180 hours. 2 hours per movie times what number makes 180? We can just divide 180 by 2 to figure out that that number is 90. This corresponds to the x-intercept of that first inequality. If I assume no time at all on the video games, but all my time on movies, I could watch 90 movies given the 180 total hours that are available to me. Similarly, if I went the other direction and said, let's only play video games this year, that would mean that my movies are 0 and I can solve for video games. 20y equals 180. Once again, we divide by that coefficient of 20 and we get that we could play 9 video games. So we're going to put that down here as our y-intercept, 0, 9. The purpose of this isn't necessarily just to get it down on a graph. Again, we can have a graphing utility do that part for us. The purpose is to get some intuition for what the possible solutions look like. In this case, maybe we'll put 90, 0 way over here. Let's just say that that's 90, 0 and 0, 9. Maybe that's a little bit too high. 0, 9 we'll put somewhere up here on our y-axis. Our first inequality is going to be the solution space below this line. That is, we're interested in all the positive values. I need to move that around a little bit. We're interested in the solution space underneath this line because we could use up to those 180 total hours. The line, our boundary, represents different possible solutions if we use exactly 180 hours. Let's do exactly the same thing with our second inequality. Again, if we completely ignore the video games and we only spend money on movies, $10 per movie for $600 total dollars, divide by 10, we get 60, 0. We could watch 60 movies this year just with respect to money. Similarly, ignore the movies for a moment. If each video game costs $40, and again we have our $600 to spend, divide by 40, and that gives us 0, 15. If we only purchased video games, we could buy 15 of them. 0, 15 would be somewhere up here, higher than our previous y-intercept, but 60, 0 would be somewhere inside here, a little bit to the left of our previous x-intercept. And again, what we're interested in is that shaded region below that line. Now, this is a very typical picture for these linear programming questions. If we have just 2 constraints, this kind of diamond shape here is going to be something we see very often. And several of these corners we already know. Now, the reason I'm specifically mentioning the corners is, and here's the beauty of this process, the solution to linear programming problems must be at one of the corners of the region. When we take this to Desmos in a second, I'll show you precisely why that is, but for now, just know all we care about are the corners. Our only possible optimizing solutions have to be at these corners. So right now we have several candidates for possible solutions to this problem. We've got 0, 9. That is this kind of upper left-hand corner here. We've got, oh, I forgot to write these down. So this is 0, 15. This is 60, 0. And so we've got 60, 0 as another possible candidate for our maximizing point. We also have this bottom left-hand corner, typically the origin, and if we're maximizing something, we would almost always presume it's not going to be maximized at the point where we do nothing. In this case, watch no movies, play no video games. But just for completion's sake, we're going to include that 0, 0. The only other corner we don't know about right now is the intersection between our 2 boundaries. And there are several ways to figure out what that intersection is. One thing you could do is take your linear inequalities, treat them like linear equations, and then solve that as a system of equations. Whatever the ordered pair is that's the solution to that system is the corner of that region. But like I said, I actually want to have a graphing calculator do this for us. I don't want to do this by hand. So I think it's time. Let's go ahead and open up Desmos. We're going to graph this system and we're going to figure out what the possible solutions are for the thing that we're maximizing, which, by the way, we haven't even looked at yet, the actual question, but we'll get there. 2x plus 20y less than or equal to 180. So we're gonna have to zoom out a little bit, figure out a good window for this. There we go, that's looking pretty good. And then the other one was 10x plus 40y less than or equal to the $600 that we have to spend, and that's pretty good. Our sketch roughly looks like what's going on here right now. We've got some points like 0, 9, we saw that one, 60, 0, and then the one we didn't know about, the intersection point, 40, 5. Let's just record that so we remember that for the future, 40, 5. Now, like I said, we actually didn't even look at the actual question. Let's go ahead and jump into the actual question here. There are, in fact, 3 of them, but we're going to start with part A. If I make 3 new friends every time I play a new video game, and 1 new friend every time I watch a movie, how many movies should I watch this year to maximize the number of new friends that I make? So we are maximizing our quantity here. Now, this is our step 3. What is our objective? What is it that we're actually trying to optimize to make as large or as small as possible? Again, in this case, it's friends, and we're going to write an objective equation. Again, objective related to goal. In this case, our number of friends, which we will call f, is coming from 1 friend per movie, so that's 1 times the X number of movies we watched this year, plus 3 per video game, so that's plus 3 times y. All we need to do now is take these 4 candidates, these 4 corners, these are the only possible optimizing points, plug them into this equation, and whichever one gives us back the most number of friends, the greatest number, is the answer to at least part A of this problem. But let's go ahead and justify that. I said I would show you why it is that the corners are always going to be your maximizing or minimizing points. So we have this equation, 1x plus 3y, which itself is a linear equation. If you put something like equal to 0, that green line down there in the bottom left corner is what it would look like. If you put equal to 10, it would kind of slowly move to the right. Equal to 20, equal to 30, equal to 40, that line is moving to the right. If we just say in general it's equal to something we're going to call f1, Desmos lets us add a slider which can kind of dynamically show us what's going on with this line. And as we move it across our space, remember the space we're interested in is that kind of diamond shape. In fact, let's go ahead and get that diamond shape down real quick. So we had corners at 0, 0, 0, 9. Where was the solution? 40, 5 was that corner there, and then 60, 0. Okay, we're gonna have Desmos graph that space in there for us in purple. All right, there we go. So we've got that purple polygon, and again, that represents the shaded region under both of our linear constraints. Any ordered pair in that purple region will satisfy both of the inequalities. What we're trying to do is maximize this black dotted line. And what I'm trying to justify to you is why is it that the corners must be the maximizing points? You can see as we move that 1x plus 3y line, it can reach greater or lower values. That's what the slider is showing us. But when it reaches a least possible value, it's going to have to be intersecting our region at just one single point, just the one corner. As we move it across the region, at some point, it will reach some other of the 3 corners, and that's where it's reaching a maximum value. So you can actually already tell here the dotted line is giving us the information that that bottom right-hand corner, 60, 0, is maximizing something. In this case, maximizing our number of friends. In fact, as long as we're having Desmos do this for us, let's just have Desmos compute it as well. Let's see, this is x2, that's y2. We've got f1 being the possible amounts of friends given these different ordered pairs, 0, 0, 0, 9, and so on. We're actually going to go ahead and build another little table here. And on the left side of the table, we just want 4 different entries for the 4 different possibilities that we're checking out. And on the right side of the table, we want it to compute f1 for us. And there it is. Those are the 4 different possibilities for the number of friends here. So for example, this first entry in our list, 0, 0. Well, if I multiply that first 0 by 1 and that second 0 by 3, I make no friends at all this year. Obviously, that's not going to maximize anything, but that's what we said about the origin. It's probably not going to maximize for us. On the other hand, if I plug in this second point, 0, 9, 1 times 0 plus 3 times 9 makes 27. And that's what the second row in that second table is telling us. Clearly, what we're interested in is where that second column, F1, our number of friends, reaches a maximum. And in this case, that is at the fourth point, 60, 0. If I make 3 new friends every time I play a video game, 1 new friend every time I'm watching a movie, and given the other constraints here, the money and the time that I can spend on movies and video games, then the best thing to do is actually just to watch 60 movies this year and therefore make 60 friends. So that could be our answer to part A. It's best to watch 60 movies. I have the money to watch 60 movies. I have the time to watch 60 movies. And so I'm going to make my 60 friends by watching 60 movies. So that's it. That's linear programming. That is a traditional linear programming question where we have our objective. The weights for the objective are given to us. That is the 1 friend per movie, the 3 friends per video game. We take the corners from those 2 linear inequalities that we graph, plug them into the objective equation, and then pick the either maximizing or minimizing point, which again in this case happened to be this bottom right hand corner, 60, 0. Just to finish it out though, this particular problem asks us to go on. Part B gives us a different scenario to consider. Part B says, suppose that actually we make 5 new friends every time we play a video game. So one thing you might have noticed earlier on in the problem is, in a sense, we get more bang for our buck out of the video games. They cost 4 times as much as the movies do, but we get 10 times as many hours of play out of the video game than we do from the movie. In one sense, that means that video games are actually very resource intensive. They cost more and they take more time. But if what we ended up seeing is that they also helped us make more friends, I mean, they already were before. 3 obviously is bigger than 1, but it was only a times 3 advantage. If instead video games actually helped me make 5 new friends compared to the 1 new friend for the movies, then I might see this relationship change. Now, this is going to require that I adjust my objective equation. In fact, here I would now say that f, my number of friends, is equal to 1 times x plus 5 times y. Again, I don't want to have to do this math myself, so I'm going to have Desmos do it, computing something I'm going to call f2. f2 equals 1 times the number of movies that I watched this year plus 5 times the number of friends. Can I get it onto the same table? Oh, very good, I can. And so now I have some new values for the number of friends I end up with at the end of this process, at least in some of the cases. You'll notice that the first and fourth points here, that is the origin and then that bottom right-hand corner, 60, 0, in those 2 cases, the number of friends remains the same. I'm still making 0 friends at 0, 0. I'm still making 60 friends at 60, 0. But what is changing are these other 2 values, because those values had non-zero numbers for the number of video games that I'm purchasing. And what we changed in our objective equation was how many friends I make per video game. Since it's 5 now rather than 3, I can see I'm making more friends at those points. In fact, it happens to be just enough that it is now worth playing some of the video games. If I spend my time and money on 40 movies this year, but 5 video games, I actually maximize my number of friends at 65. That's coming again from 1 times 40 is 40 plus now 5. I've changed the weight. 5 times 5 makes 25. And 40 plus 25 is 65. One last little question here, part C, very weird question unless you're using something fantastic like the Desmos graphing calculator. Suppose I want to make as many new friends as possible. What is the smallest whole number of new friends each new video game must give me? Assume I make the same number of new friends for each game I play, and that I make 1 friend per movie. So we're basically holding the 1 friend per movie constant, but now instead of necessarily 3 friends per video game or even 5 friends per video game, I get to pick that number. I get to choose the weight. What would be the first whole number of friends per video game where it would actually make sense to only spend time and money on video games? Like I said, Desmos makes this pretty easy to do. We're just going to write this equation here. We're going to change the weight, not 3, not 5, but C. We're going to have Desmos add a slider. They said it had to be a whole number, so let's assume it's going to happen. somewhere between 0 and 20 friends per person. And again, we actually already know that when we move from 3 friends per video game to 5, that the video games are starting to look more attractive to us. Put in one more row here for F3, and all I'm going to do is kind of adjust this slider. And what you can see happening, again, those middle 2 boxes are the ones that are changing, because as we're increasing this weight, we're making video games more and more popular. We want to know the first number where we can do only video games. You'll remember that only video games was the second level, so I'm looking at this second row. And right now at C equals 9, that is 9 friends per video game. It's not quite better. It's still worth spending some time on movies. That's what I'm seeing in row 3. If I bump it up to 10, however, you can see that these 2 rows are now equal. And finally at C equals 11, it's actually better for me if I just spend all my time on video games now. I promise this imaginary scenario is going to be the only time where it's best to spend all your time on video games. But the answer there, make the weight 11 friends per video game, something like that. Whew, long process. Okay, but that is how I would approach this question. That is how I would approach linear programming questions in general. Again, really focus on these 3 questions. What are our constraints? We're going to use that along with the variables we assign to build the linear inequalities. The solution to our system, the solution to whatever the optimization problem is, has to come from the corners once we graph those linear inequalities. And the way we figure out which corner is best is we write an objective equation and we just plug those numbers in. In this case, I got Desmos to do a lot of the math for us, but you can tell it's not terribly difficult to just plug in 0, 9, multiply by 1 and 3 or 1 and 5, whatever the weights are, add it all together and look for, in this case, what got us the most friends. In the future, you might minimize something instead. There are lots of possible objectives, but that's the basic outline of the process. I hope that has been helpful for you. If so, like the video, subscribe to the channel. For my students who are watching, hey, thanks for watching all the way to the end. Hopefully this will help you on the test. I will see y'all next time.
See ya! Please definitely like and subscribe. My dad's videos are super good. Never.